So again, we decided that there were sort of two different strategies that we could employ to determine an equation for a line. Sorry, to graph a line. I'm going to start that over. So at this point, we know that there's two different options for how to graph a line where what we're given for that line is an equation in its standard form. So we don't know its slope, we don't know its y-intercept, so we can't, at least right off the bat, use the slope and the intercept to graph this line. So we saw how the path of least resistance, in a sense, was to just find the intercepts, find the x-intercept, find the y-intercept, plot those 2 points, and then just connect the dots. So that's what we just did in the previous example. And to me, this is the quickest way. It's also the way that's least prone to making common slips and errors in your algebra. But let's look at that second option. Let's suppose that we want to use something that's a little bit more sophisticated to graph this particular line. So in this strategy, what we're going to do first is take the equation, which is given to us in kind of a clunky form, this standard form, and let's rearrange the equation. Let's solve for y. If we get y by itself, then we should be able to use y equals mx plus b. Well, how are we going to get the y by itself? First thing we should do is, again, because we're trying to isolate a variable, we're going to use the order of operations in reverse. If there's any subtraction or addition that we can do to make it so that the y has less stuff surrounding it on the left side of the equation, then we should do that first. Subtracting 2x, so subtracting that first term on the left-hand side from both sides, will make it so that on the left we have just minus 5y. And then on the right, we end up with negative 5 minus 2x. Now there's no addition or subtraction we can do to make y have less stuff surrounding it. So what about multiplication and division? Yeah, we can divide by negative 5. So if I divide by negative 5 on the left and I divide by negative 5 on the right, I end up with y by itself, which is what we want. And on the right-hand side, negative 5 minus 2x, all divided by negative 5. Okay, but that's not quite in the y equals mx plus b format that we're looking for. So let's simplify the expression that we have on the right. I've got subtraction going on in the numerator of this fraction, and subtraction and addition can be split apart in a fraction when they happen in the numerator. So I'm just going to split apart that division to happen to each of the terms from the numerator. So minus 5 divided by minus 5 minus 2x divided by minus 5. Negative 5 divided by negative 5 is 1. And then I end up with minus negative 2/5 x, which we can turn into plus positive 2/5 x. And this still doesn't quite look like y equals mx plus b, but don't be fooled, right? Because what's most important about mx plus b is which is the coefficient of x and which is the coefficient which is just the constant. The coefficient of x here is 2/5. So 2/5 belongs in that box right there, attached to the x. And the constant term, the number which has no variable factor attached to it, is the 1. So our equation here is y equals 2/5 x plus 1. Great, so what does that mean? Well, first things first, we're going to look at the constant, the number that's just by itself. That's the y value that we would get if we were to wipe out the other term. If we were to wipe out the 2/5 x, we would be just left with y equals 1. Well, how do you wipe out that term? You plug in x equals 0. And if I plug in x equals 0 into an equation, I'm talking about that equation's y-intercept, where it hits the y-axis. Therefore, y equals 1 is the y-intercept of this line. That's something we determined using option 1, taking the other strategy before. Okay, great. So that's what the constant tells us. What about the coefficient of x, this 2/5? Well, this is the famous quantity for a linear equation that we call the slope. So let's think about what slope is and how it can help us to finish graphing this line now that we have it in its y equals mx plus b format. So the slope of this line is 2/5, but what is a slope in general? Every slope, no matter what disguise it wears when it comes to you, is nothing more than a ratio, the result of a division problem, whose numerator is what we call a rise and whose denominator is what we call a run. And to unpack that a little bit, a rise is nothing more than a vertical difference or vertical distance on the graph paper that we're looking at. And the run is nothing more than a horizontal distance on the graph paper that we're looking at. So if I have a fraction whose numerator is 2, and I'm interpreting that fraction as a slope, what we can do is say that that 2, that positive 2 upstairs, represents a rise of 2 units on our graph paper. In other words, it means that we can look at this as a change where I go up by 2 spaces on my graph paper. But when that happens, I also have to go horizontally somehow, and that's what the denominator tells us. Here the denominator is 5, and if we interpret that as a run, then because that number is positive, that means I'm moving toward the right. I'm increasing my value of x, if you like. By how much? By 5 units. So what the slope is telling me is that if I start at any point on this line, and I go up 2 units, and then to the right by 5 units, what I'm going to do is I'm going to land at another point on that line. So if I just do that on my graph paper, starting from my y-intercept 0, 1, because I know that that's a point on my graph, I go up 2 units to land at 0, 3, and then I move over 5 units to the right to land at the point 5, 3. That gives me a second point on this line, and as soon as I have that second point, I can just draw my line and be done with it. So this was the more sophisticated way to graph this line given to us in standard form. It was a little bit more work. You'll notice we did a lot more algebra to get to our answer. But the nice thing is that now it gave us a way of really understanding the relationship that this standard form equation describes for us. We know based on the slope-intercept form that we got, y equals 2/5 x plus 1, that the y-intercept of this equation is at y equals 1, and that the slope of this equation was 2/5. And we unpack that by saying that if the slope is 2/5, that means that I can rise by 2 and run by 5 and go from one point on the line to another point on the line. Rising by 2 just means going up 2 units. Running by 5 means going to the right by 5 units. So if I do that, starting from my intercept, I will land at another point. And as soon as I have 2 points on my line, all I have to do is connect the dots. And that's all we need.